Okay, so back from the midterm, I hope everyone has had a chance to look at their scores and the solution sets. After you look at your scores and your solution sets and the individual responses, things like that, if you have any questions, feel free to let me know. Otherwise, kind of moving forward here, now we're sort of in the back half of the class where we've learned the basics of modeling. And so in this first section here, we're going to be talking about how to make these computational models more realistic, more complex. And so that's kind of this unit. And then after this unit, we'll then start looking at kind of case studies of where dynamical systems modeling has been used to gain insights into a lot of problems that many of them kind of relate to sustainability. And so we'll kind of see those examples. And that'll also help give us practice in building out these equations and how to model these things, which will be important as you go into your final project. As I mentioned online, looking to make sure that you've got your teams submitted by, I think it was by this Sunday. And so if you're having trouble finding team members, I encourage you to take a look at that Google spreadsheet, either reach out to people who've already put their names on there or put your name on there. If you've already put your name on there, go back to the spreadsheet and reach out to people who have added themselves. Otherwise, feel free to post on the discussion boards. Feel free to post on a Slack, etc. However you'd like to make those connections. So we're looking for teams nominally, shoot for 4 people. Really like to see mostly 4-person teams, but occasionally a 3-person team will be acceptable, but it'll be better for the experience if we can get them to 4-person teams. All right, so any questions about that from in class or online? Okay, so in that case, then sort of moving forward, one of the first things we're going to do then is in Vensim and Insight Maker, learn how to do some basic embellishments where we're going to learn about units and lookup tables will kind of be our primary things today, and then on Tuesday, delays. And so let's see what that looks like. So both of these platforms have support for units. We haven't used them so far, but we've talked about this idea of dimensional analysis in some more the previous Moorcroft chapter, where if we specify units, then Vensim and Insight Maker can help sort of keep us honest in when we're doing these expressions. And so if we put an expression together and the unit doesn't come out to what it's supposed to be, then Vensim or Insight Maker will say, hey, I think maybe some of your logic might be wrong, or some of your units are wrong. Can you go and double check? And so it's a good thing for what we refer to as verification and validation. So the first unit that is we have seen is under the model settings in Vensim, where you set your time step. And then a little bit down here, you have this units for time, second, is what's selected here. And so far, that's just been the thing that's been on the x-axis of these behavior over time plots. But we want to see, other units that we can go into here. And so inside the equations in Vensim, and I could open up Vensim and do this as well if that's helpful, but this is the same equations box that you've seen. It's a little bit cleaner in the newer version of Vensim, but it's the same basic idea. And up at the top, there is a units that we've so far left alone. And so what we can do is we can drill down on those units, and we'll see that there's a bunch of provided units like DMNL, that's just a synonym for dimensionless. There's also time units like second, minutes, etc. But then you can actually go and put in your own units in there, and it knows what a slash is. So if you do meters per second, it knows that that's 2 units. That's sort of a quantity unit meters divided by a time unit. And so because it understands that, then inside the expressions that you type in inside this box, then it will expect that you to effectively be doing a division or multiplying an existing unit that's meters per second, and using that through. So it doesn't understand the word per, but it does understand the slash. And so you can just type in your own units there, meters per second, meters, germs per month, and so on. You can just put that up there into that units field. And then you can click this check units button. I'm just trying to get a hold of my mouse here so that I can All right. This check units that's up here, if you click that, it will then look at the expressions that you've typed in and it'll verify the consistency to say that, yep, you wanted this to be meters per second and the expressions you've typed in here are meters per second. So that's a quick way to check on your equations. That's one way to do that. And then, see, I somehow got out of Excel or PowerPoint. Let me see if I can get back. Yeah, okay, and then you can also specify unit equivalents. And so it's really a drag to say like every time you want to use meters, you have to use meters and not meter, because sometimes it's just going to feel right to do meter and not meters. Sometimes it'll be meters. So sometimes you want to use a singular, sometimes you want to use a plural. Sometimes you might want to use centimeters. Sometimes you might want to use kilometers. So if you go back to that model settings where we normally are just worried about like under time bounds where we've got all the parameters like time step, there's a tab over here called units equivalent. And on the new version, I think it's, it might be down the side here, but it's the same thing as there. And what you can do under unit equivalents is you can set up synonyms where you can say that like, I can use a dollar bill, the word dollars, or a dollar sign S. And all of those mean the same thing. I can use day or days, and all of those mean the same thing, and so on and so forth. And so you can click add, and you can add these synonyms here, and that allows you to use any of the synonyms anywhere throughout the model, and Vensim will just replace it with, it basically knows that those are all equivalent. So internally, it'll view those all as the same unit. So that allows you to use the singular sometimes, the plural some other times, and so on. What we'll see is in Insight Maker, it gets even fancier where you can actually specify mathematical synonyms. So you can say that a kilometer is 1,000 meters. So in that case, you can actually sort of scale your units as well. Whereas here, there's no mathematical equivalence. It's just purely like, what's the plural form? What's the singular form? That's all that's being done kind of here. So does everybody see what I mean by synonyms? So this is just a way to tell Vensim that when I say either of these words, I mean the same unit. And you can put in as many synonyms as you like. You can edit the existing list. I think it's blank by default, but then you can add your own as well. And then you can use those throughout. If you don't set this up and you do a week somewhere and a week's plural somewhere else, then Vensim will say, hey, there's a units mismatch. And then you have to go in and set up this synonym. Okay. I see a question. Are these settings global across projects or on a per project basis? This is a question from the chat. It's a good question. These are per model. I think that you can make these down here. See where it says make these synonyms the new model default synonyms. You can do that, and then that will make them the default across all new model, but not any existing models. So the new model defaults, I think, start out as blank. You can change them so that all new models use whatever you put in here. You can replace these with whatever the current new model defaults are. But generally, when you're adding these here, these are just within the current model, not all models. Okay, any other questions? All right. I showed you I can do a units check on an individual equation. Across the whole model, you can do a units check as well. So you put in all your equations, and before you want to run it, then you can go up to model in Vensim and go down to units check. And by the way, there's a homework that's available that you can start working on. It's not technically, I think, released until I think maybe Tuesday. But the first question you'll be able to do after today, and the first question involves using units. So you'll get a chance to practice this. So under the model menu, you can go down to units check, and it will go through all of your expressions throughout the entire model and see if everything matches up. And if it doesn't, it'll throw up an error. It'll tell you where you need to make those edits. So that's a way to check for unit consistency automatically. All right, so that's how we do it in Vensim. And I also want to show you how to do it in Insight Maker. So any questions about the Vensim? If anybody needs me to show you it in actual Vensim, I can, no trouble, popping up Vensim and showing you here in the newer interface, but otherwise they're very similar to these screenshots. Okay, all right, so Insight Maker has got this as well. The older version of Insight Maker at the very top, it had settings. Now I think it's a little gearbox, but the same idea. And if you go up to here, inside those settings, then as before, you got your simulation time step, but they also have the default time units, just like Vensim, and you can set those. Now, you can also set units in each individual expression for flows, for variables, and for stock initial conditions. And here I've actually replaced these with screenshots from the new version because the old version is significantly different looking in where units are located. So I really did have to go through and just redo these slides. So that's why it looks a little different than some of the rest of these slides where I didn't go and rebuild the models. But so the idea here is if you draw a simple model here, if you click on either any variable in here, so a stock, a flow, or an auxiliary variable, if you click on any of those, then on the right-hand side, you get this little editing pane that allows you to edit the expressions here. And we've seen that if you click this little box up here, it'll give you an expanded view so you have more room to type. We see that if you start typing in here, if you have access to variables, they'll pop up down here. And it even gives you a little stigma that pops up that if you hit that, it actually shows you a bunch of functions that you're allowed to use. So this is, that. So here I've got a flow rate that I've put in 1 down here. If I look down a little bit farther, and notice I left it at the default, the only positive rates. I normally turn that off. It's just good practice to turn that off, but I just left it at the default for this example. And if I look down here, because this is unit list, it says choose units. If I would have already put a unit in there, it would have actually said the unit. If I click on that choose units, it pops up a new dialog where it has a whole list of units that are already available inside Insight Maker. And so I've expanded some of these so you can't see them, but down even farther here, like this is a scrollable list. It's got it's got mass, it's got volume, so here we see distance, area, and volume, and here I'm only seeing distance, but further down it's got area and volume. Like I said, further down even than that, it's got things like mass, and it's got liquid units and all those sorts of things. So it has a bunch of units pre-built for you. And you can notice it's got millimeters, centimeters, and meters. So it's got actually the SI prefixes already bundled on there, and it knows how to convert among all those. And so if you use millimeters somewhere in a model and meters somewhere else in the model, it knows to scale those appropriately. And then up here, any units you've already used in the model, it just keeps track of because it knows you'll probably use those again. So initially this list will be empty, but this year I've already used meters and meters per second inside here. It understands the word per. It also understands a slash. So there's a lot of things that makes these units a little kind of visually appealing inside Insight Maker. So, but it's very similar to Vensim. You click here, you click your units, and then you've got the outgoing units for this thing here. And when you click simulate, it automatically does a units check. So I can also then type in custom units. And so here, meters per second isn't a custom unit, but if I wanted this to be like germs per hour, if I'm talking about a growth rate, it doesn't have a germs unit. And so if I did germs per hour, if I did germs per millennia, maybe it doesn't have a millennia, it would automatically create a germs and a millennia and a germs per millennia that links them together. So you can name the units whatever you want right up there. So just like you can in Vensim. And then you can also do those synonyms. But like I said, the synonyms here, you can actually make them kind of scaled synonyms. So if I go down in the unit box, this custom conversions, if I click on that, it'll bring up a dialog where I can then add in synonyms just like in Vensim, but I can put scale on them. So if I already have germ in my model, I can say a foreign germ is just 15 germs. And it'll know that everywhere I use foreign germ in my model, it will internally multiply it by 15 and replace it with germs kind of behind the scenes to keep everything in the same unit. Likewise, I can say that a foreign germs plural is just one foreign germ singular, that those are just a direct synonym. And then I can also say that germs plural is just one germ singular. So I can not only create the simple synonyms down here, like these 2 rows that I do in Vensim, but also these scaled ones up here. This is really nice, and that allows you to do things like creating a kilogerm, a milligerm, a centigerm, etc. So does this make sense, this idea of the scaled synonyms for your units? Okay, any questions online about that? Okay, good. So what other things can we do here? Well, if I, and let's say I'm looking at the flow here. So I clicked on this flow and it's brought up this thing here. And I've already said that flow is in meters per second. Like that's just the expected output for meters per second. So whenever I refer to flow in formulas elsewhere in the model, then it will be in meters per second. But then let's say I go to the internet and I look to see what should this flow actually be based on real world data. And all the real world data I get actually specifies this flow in centimeters per second. Now, I could change the unit for flow, or I can actually put inside the expression here a unit, what we call a unit literal. So I can put a little curly brace. So, but remember, before this was just 1, which would mean 1 meters per second. But if I put the little curly brace here, then that tells it that the thing immediately following the curly brace is the magnitude. And what's going to come after it is the unit. And then another curly brace to close that out. And that tells Insight Maker that it should convert this unit into this unit. And if it doesn't know how, it'll throw up an error and say, I can't do that conversion. But it knows how to convert from centimeters or from centimeter singular to meters plural. So it's not going to have no problem with this here. So if you've already built your model with certain units down here, and then you look up data that you want to then plug in and the units don't match, you can either do the conversion yourself, or if you're afraid that you're going to move the decimal the wrong way or something like that, you just put the little curly brace in, and then you can put in the units here and then let Insight Maker do the conversion for you. Does that make sense what I mean by putting literal units in here with the curly braces? And you can then do math as well. So I could have done 1 centimeter per second, then outside the curly brace times 5 or something, and then it would convert it to 5 centimeters per second. And then eventually then convert that into meters per second before it actually does the sim. Okay, questions online? So these are things that not as easy to do in Vensim, so it's a little bit more elegant in Insight Maker. Okay. All right, so how do we then check consistency? I already mentioned it before. If you go up to simulate, it will not run the simulation unless the units check out. So if you hit simulate and your units don't work, then it'll throw up an error, and that error will tell you where the mismatch is so that you can go in and fix your formula or your units, whichever one is incorrect. Okay. So questions about either of those? Or does anybody need me to actually open up in either one of those programs and do an example, or maybe see what the errors look like or anything? All right. Like I said, you'll have a chance to practice this on the first question of your homework, where you have to put in the units. And I think I do something where maybe you have to, like, I give you most of the units, but you have to fill in one of the blank ones or something like that. So you'll have a chance to see how these work in either program. You don't have to do them both, just pick whichever one you like. Okay, so the other things that we can do that's going to be, and this will be really helpful for that homework as well, is something called sliders. And both Vensim and Insight Maker provide sliders, and I've got a video tutorial on how to do more sophisticated versions of these. But the basic idea here is that maybe I could build one of these in Vensim to see this live, but what we can do is, if you build a model in Vensim that has constants in it, normally we hit the simulate button and then graph. But there's this little button next to simulate that's called synth the sim. And when you hit that, it will turn all of your constants, so down here, this parameter and this inflow, into little sliders. And again, maybe I could do this live and it'll make more sense. Let me open up Vensim. But then the idea here is that you can drag these sliders around, and then in real time, all of your dynamical variables that aren't constants will have a little thumbnail of them with their behavior over time, without any axes or whatever, but just the shape of their behavior over time drawn out. So you'll be able to do that to be able to sort of say that you're looking for qualitative changes in system behavior, like the point where, like, I'm going to ask you to do this in the homework. I'll ask you, what is the critical number of ships in which this fishery becomes unsustainable? And you're going to look for a point where the fish population goes from being, sitting at a steady value to, when you drag the number of ships just one too far, it crashes. And so looking for that point where the fish crashes, it's a great way to just search for these parameters visually and then say, aha, without doing any of the math, that once I get up to 42 ships, that's exactly when the fishery crashes. So this fishery can only support 41 ships, as an example. I don't think that's the right answer there, but just as an example. So let me bring up Vensim here, and just so I can show you this real time, because it might seem a little abstract at this point. So, so I'll pull over. I have a feeling this is going to be a little big for the screen, so let me shrink it and pull it over here. Okay, so I'm going to just do a super simple example here. So I'll just do like bacteria. I'll do a flow. Let's call it births. I'll do an outflow, call it deaths. I'll do a delete that guy that I didn't mean to put there. So then I'll do an auxiliary variable, which will end up being a constant called death rate, and maybe this one called birth rate. Connect these things up as we've seen before. Birth rate to births, death rate to deaths, bacteria to deaths. Stop me if you've heard this one before. Bacteria to births, maybe. And then if I go into the equations, sure, you can save. If I go into my equations, which I think the equation guy is a little far out, so let me try to open this up a little bigger. There we go. And I'll go into bacteria. I'll set it to a, need to get the dialog opened up on my other screen, so drag it back over here. Initial value of bacteria 1. My birth rate is just bacteria times births or birth rate. My death rate or deaths is just bacteria times death rate. I'll set my birth rate to 2, and I'll set my death rate to 1. So right now they're being born faster than they die. So if I go and I could just go and hit run, simulate, that's what we would normally do. And again, this would appear like nothing would happen. But if I go over here and do the sim instead, then after I click on that guy, oh, and I've got so it popped up a dialog asking me if I want to overwrite my data set, which I do. So let me get that dialog out of the way here. So yes, overwrite. Now we see that I've got sliders. And so it's subtle because the exponential growth, but you can see that at this current setting, the bacteria starts flat and then it skyrockets up here at the end. Likewise, birth starts flat, skyrockets up. So I can go down here to this birth rate and I can drag it closer to the death rate. And I overshot there, but if I get it close, so right there, now my birth rate is less than my death rate. And so you can see here, now instead of growing, it declines. So I can play with these sliders and it's simulating every time I drag and let go of the slider. And so with that, I can search for these sort of critical points of changes in behavior in my system just by sliding this thing around. And I can do that with birth rate, I can do it with death rate. it sets up a slider for anything that doesn't have a formula, anything that's a constant. Birth rate is a constant, death rate is a constant, and that's why the slider showed up there. Anything that's a formula turns into a little thumbnail of the behavior over time. So that's how that works. Are there questions about that? Does that make sense, how the sliders work? Questions online? All right. So I'll go and I'm going to go up here and hit stop Synthesim, and that makes all of that go away, and it stops Vensim from trying to notice changes and re-simulate. All right, so, and I've put a tutorial on Canvas for how to do even more sophisticated things, like you can actually embed a behavior over time plot that actually has proper axes and everything that's right inside the canvas. And then as you drag the sliders around, it'll automatically change. And so that's a little more advanced. If you're interested in seeing how to do that, I've got a tutorial to show you how to do that. All right, and we can do a very similar thing inside Insight Maker as well. So any constant, like this new variable here, you click on it, and down the right, it looks a little bit different in the current version of Vensim, but still down the right-hand side, there'll be a little checkbox that says show value slider. If you set that equal to yes, then when you click on the blank canvas, then you get sliders out here. And then you can slide those sliders around and they just change the constant here. Now, it doesn't automatically simulate. It requires you to go up and hit simulate, but it's a quick way to change the value, hit simulate, and it'll show you results. And if you leave those results up and then change the value again and click simulate, it'll put new results in a new window. So it's not quite as nice as Vensim. This is kind of where, I think in units, Insight Maker wins. In sliders, Vensim wins. But it's still not that bad. So, so that's kind of how that works. And so we can do those sliders. And again, that just makes it so that when you hit simulate, it'll use that value instead of the default value that you typed in initially. So any question about the sliders in either Vensim or Insight Maker? And I can show you how to do this in Insight Maker, but like I said, it's not really that exciting relative to Vensim. It just makes it, it's just basically a shorthand for, so you don't have to click on the variable, edit the number, click on the variable, edit the number. It's just kind of a quick way to do it. Okay. Questions online? All right. Okay, so I think the last thing that I want to cover today are lookup table converters. This is sort of the most sophisticated thing we're going to cover today. Super important. Traditionally in this class, one of the more difficult concepts to get used to, but we've seen them a lot so far. We're now just learning how to build them in Vensim and Insight Maker. So lookup tables capture relationships graphically instead of with a mathematical formula. So they're called lookup tables because normally with a mathematical formula, you put in an input and you calculate what the output is with an expression. But in a lookup table, you actually draw a graph relating input to output, and it looks up what the output should be based on that graph. So that graph is really like a dictionary where you can say for this input, this should be the output. For this other input, this should be the output. If it's an input in between them, the output should be in between those two outputs. So that's why they're called lookup tables. In Insight Maker, they're called converters. It's a little confusing because we use converters a little bit more liberally in the Moorcroft text, but you just have to get used to that. So again, we've already seen this. So this is our classic fishery example, which you'll see this again on that homework. And it's got its stock, it's got its regeneration, its births, new fish per year. And there's this net regeneration lookup table. So if you remember, this is a graph which related fish density to the net regeneration rate for the fish population. So the idea here is that if you look kind of closely, there's a bunch of corners on this graph. So there's what 369 of those little corners and straight lines connecting them. So you can define this graph by those 9 points, and it just draws a line in between each one of them. And the result maps any density from 0 to 1 to a bunch of regeneration rates. And so the idea here is if the simulation currently has a density of whatever this is, 0.15 or something like that, it will then go up and say, hit this line and say, I should make the net regeneration where it hits on the y-axis. If the density in the simulation changes to a higher density, like up here closer to 0.5, it says the net regeneration should be up here. And we can keep doing that game, whereas the density moves around, the sim changes the net regeneration. This is so far up until this point in Vensim and Insight Maker, to represent these relationships, we had to come up with a formula that said when the density is this, the net regeneration was like density squared times 5 or something like that. Well, now we don't have to use a formula. We just draw out the graph of the relationship, and then we let Vensim and Insight Maker make this happen for us. So are there any questions about this general idea about the lookup table? Does this make sense that we're getting rid of the math expression, and that allows us to do more complex relationships between inputs and outputs? But it requires us to write them in this kind of ugly format where we're going to have to write in like a bunch of points that end up getting connected together in order to span the space. Okay, and this is traditionally a difficult topic in this course, just across instructors and things like that. So want to make sure we give it enough time. So in the Moorcroft text, when you go this, now that we're a little more sophisticated, we can look at his fisheries model. And if we look down in the text, he always has his equations. Whenever there's a lookup table, he puts the lookup tables in there too. And that's what I want you to do as well, is I need you to give me the points in your lookup table whatever you're drawing something like this, when you list your formulas, then you also have to list the points of your lookup table. So like this lookup table here is identical to this one down here. It's identical to this one right here, where he says net regeneration equals graph fish density. So this is the Stella format, where graph means it's a lookup table and fish density means the input is fish density. And then each one of these, whatever 9 or 10 points, represent 4 pairs of fish density regeneration rate groupings. So when you have 0 for density, you've got 0 for regeneration rate. When you have 0.1 for density, you have 50 for regeneration rate. 0.2, you've got 100. So if I look up here, I can see, well, 0.2, it corresponds to 100. 1 corresponds to 0. 0 corresponds to 0. I was supposed to have 0.150. I think when I drew this, I left that point out, but because it's on the same line as this 0.150, 0.2, 100. So that's why it doesn't look like it's there, but it's just because it's on the line there in between. But these 9 or 10 points correspond to these 9 or 10 points. So that's how we show a lookup table to our stakeholder, to our reader. We just list the points out. Does that make sense? Everybody know how we go from this to this or vice versa? Online, everybody okay? All right, so how do we implement these things? So in Vensim, the old version of Vensim, there was an advanced version of lookup tables, which I have slides on, but I'm going to skip over them. I just left them in there if people are interested in it. And I could usually hide and say, don't worry about the advanced lookup tables. We're not going to do it that way. We're going to do it kind of more like Moorcroft does it. But in the new version of Vensim, they snuck their advanced lookup tables up here into this lookup in the up in the toolbar there. And that's when you start using lookup tables, then eventually this becomes a comfortable way to do it. When you're starting out, this is not. So just forget that lookup exists there. When I tell you, or when you draw lookup tables in your homework, unless you really want to be ambitious, this is not what we want here. So don't use that lookup button. Just imagine it doesn't exist. That lookup tool is non-existent. Instead, we're going to implement lookup tables through the equations tool. So if we were to draw this fishery model, we would just create a normal auxiliary variable, a normal variable right here called net regeneration. And then we would go into the equations button, just like any other variable. And when we do that, it brings up the equations box. And up here under type, we're going to leave it as auxiliary. That will be the default type for anything that has something coming into it. So if it has an input, it'll automatically make the type auxiliary. But then under subtype, we're going to make this with lookup. If you happen to click on type, one of the other types is lookup. That's that advanced one that I don't want you to use. So, don't give in to the temptation to click on type and go down to lookup. Type will always be auxiliary. Leave it as auxiliary. Only use subtype with lookup. And that'll make it just like how Morecroft has it. That way we can be consistent across the class, and it'll also make it consistent with Insight Maker. So subtype with lookup. Then what do we do after that? Well, in this upper box where it says with lookup, we put the input to the lookup table, the horizontal axis. So in this case, it's fish density. That's the only thing coming into the lookup table, the only thing we're allowed to use there. And then we need to put our lookup table into this box down here. Now we can manually type it in if we're really, we know our stuff. But fortunately, there's a little button called as graph that makes it a lot easier to put this thing in. We click on this as graph, and then it gives us this box where we can input all our points in. And so you can either use your mouse and click around the lookup table so that you can put these points in visually, or you can just type them in. So you can go down here under new and type a new point in, or you can go up here and you can edit a point, you can delete a point, and so on. And so if somebody gives you 10 points, you just fill in the 10 points here and it draws them out. And then just for visualization purposes, you can change the limits for the horizontal limits and the vertical limits. And that can make it sort of look a little bit better as you're putting it through here. And then I think you can also, I don't think you specify the fish, the units, the output units for the lookup table are still specified here, but it will just remind you of the units over here that, by the way, you're specifying fish per year. So make sure you're scaling your output appropriately. So even though the units show up here, you edit the units back on the previous screen. So this is how you enter lookup tables in to Vensim. So any questions about this process? I'm happy to show you that if that's helpful. Questions online? There are little shortcuts down here, clear all points, clear points, etc. Okay, so then after you click OK to that graph, then down here, it shows you a list of points. So it shows you over here, the first thing is going to show you the bottom point, the bottom corner of your graph and the top corner of your graph. That's just for visualization. It doesn't really mean anything. But then after that, it shows you all of the points that you put in there. So again, once you do this enough, you start recognizing the syntax, you can start reading it. Eventually, you actually get to the point where you can actually just start typing that out without ever having to even go through the as graph. But for the purpose of this class, it's totally okay to use that as graph tool to simplify this. And then once you've done that, and so this is me just saying that's the range, see the bottom left and the upper right. And then these are your 9 or 10 points. So those points match up with these points. Where again, I forgot when I implemented this at that point, but otherwise they're all the same. So everything clear? Any questions? Yeah. So like when you're reporting it like in a Word doc, yeah, when you report your equations, I want you to tell me all of your equations, all of your initial conditions, and if you have lookup tables, all the points that are in your lookup table. Everything that someone else would need to hand draw your simulation and reproduce it. All right, any other questions? Great. All right, so with that, if I go and simulate this, I get something that looks like this, which matches what Morecroft got. So he plotted both the population and the regeneration rate, and his regeneration rate went up to 1,000 and mine went up to 600, like just the axes. So that's the reason why this little spiky thing is a little bit, looks higher than this one. It's just the axis scaling, but otherwise I get the same results that he does. So I was able to re-implement, what he had in the book there, and you could too. All right, so that's Vensim. So how do we do lookup tables in Insight Maker? Lookup tables in Insight Maker are very similar. Oh, so right. I'm going to skip these slides, but just if you're interested in using that fancy lookup tool or seeing how to use type lookup to build things that look like this, where it's a little weird, where the fish density goes into new fish per year and the lookup table itself looks like a constant going in, then you're welcome to try this out. But I'm going to skip this, but I'm just leaving the slides in there for you to have that info about how that works. Something else that I just want to mention is if you combine this with SynthTheSim, this or the other one, if you click on lookup tables while SynthTheSim is turned on, you can edit the lookup tables in real time. So that's kind of cool that you can drag those points around as the simulation is running. So I'm not going to ask you to do that, but I'm just letting you know that you can do that. Kind of a neat feature. So I'm just going to skip through those slides, those extra slides, so that we can get back to how to do lookup tables in Insight Maker. Or, sorry, we'll do advanced lookup tables and then we'll go to Insight Maker. All right, so advanced lookup tables in Vensim. So this, let's say I've got a savings account balance. What I want us to be able to do is have an interest rate that changes with time. So if we wanted a constant interest rate, so say our savings account balance had a 1% interest rate, we know how to do that. But I want to be able to actually take time as an input and turn this interest rate into a lookup table where I can actually schedule different interest rates at different times of the year. That's my goal here. So let's start with the simple example of the fixed interest rate. So if I draw this in Vensim, got a stock savings account balance, a flow going in interest, a constant fixed interest rate coming in here. And so these are my equations for each one of these. And so the stock, I don't ever touch the end tag. I just do my initial value, $100 in there initially. The interest rate or the interest flow is just going to be the savings account balance times the interest rate. And then the fixed interest rate is just this constant where let's say I did 10% APR. Well, that would mean 10% divided by 12 compounded every month. And so that's why I do 10% divided by 12, but it's just a constant put inside here. So that's how I do the fixed interest rate case. Now, and then if I were to simulate that, I'd get something that looked like this, where the blue line is my fixed interest rate, which is constant, and the interest generated is the red, and the actual money in the account is the green. So that's our simple simulation of our bank account. Now, what if the interest is not fixed? What if it changes over time? January is one interest rate, February is another interest rate, and so on. How do we implement that? Very similar, but we're going to turn fixed interest rate into a lookup table, and we're going to show you how to introduce time as a variable which you can use. So I need to do the time thing first. And so there's this thing up here called shadow variable. And that's what we're introducing, these shadow variables. Now, in the new version of Vensim, there's not only shadow variables, but there's something else next to it called existing variable. Ignore that. I can talk to you about how to use that existing variable, but it's a little more advanced and it's really just a visualization thing. So ignore the existing variable. It looks really similar to shadow variable. Make sure you click on shadow variable when you're doing that. So you click on shadow variable and it'll pop up this thing and it'll show you all variables that already exist, plus a few special variables that are hidden behind the scenes that you now can get access to. One of them being time. So if I click on shadow variable, pops this thing up, I click on time, and then I plop down a time right there, then that acts like a variable, which actually gives me access to how what the clock is inside my simulation model. So shadow variables are aliases to existing variables. So other ways I could use this is, let's say, notice interest or notice savings account balance shows up here as well. If I wanted to draw other things on my model down here, but I didn't want to create long range connections between here because it just would look ugly, like to have all these lines going across my model, I can create a shadow variable for savings account balance. It'll create like a little copy of it down here, and it'll look like that. It'll have little brackets around it. It'll be grayed out down here. And any links that go to or from that shadow variable effectively go to or from the original variable as well. So it allows you to sort of create a ghost copy, a shadow copy of whatever your whatever variable you point to. And again, you have access to all of them, and then you can use them elsewhere in your diagram, and that can simplify the drawing of the diagram. So it simplifies the drawing of connections, and it gives you access to a few variables that are behind the scenes, like time. So that's what shadow variables are. So any questions about that? What I mean by shadow variables? So in this case, we're just trying to get time out there. Questions online too? Okay, so I've got access to time. So this is just like, it's whatever unit you put your time units in. Let's say you put your time units in as seconds, and this would be seconds since the beginning of the simulation. That number comes out of time, and then you can make use of it. So what I can do now is go into my new variable interest rate instead of fixed interest rate. I change it, it was an auxiliary, but I do the with lookup again. And time now shows up as one of my inputs, as I would expect, since I drew it as an input coming in here. I again change this to be with lookup based on time. And then under my as graph, I can create a schedule of interest rates. Now, in my case, I set my time unit in this case for months. And so I said I want to define interest rates to change over a 4-year period. So I defined my minimum for this lookup table as 0 months, my maximum to 48 months. And so if I'm simulating for 48 months, then this lookup table allows me to change my interest rate so that it's this much for so many months. So for the first year, so notice that, so it's this interest rate up until about the 12th month. And then it jumps down to this interest rate for another roughly 12 months. And then it jumps up to this interest rate for another roughly 12 months, jumps down to about nothing for half a year, jumps up to an interest rate for a quarter of a year, and then jumps up for the rest of the year to there. So I can define an interest rate that's jumping all around, just by, and then I've got all these points here. So this thing I actually did graphically, which is why these numbers aren't quite perfect, but just shows that you can click on the graph to create these, and I can create these nearly vertical steps as well through this process. So this is still about the same. All that's new is I use the time variable instead. All right, so with that, I can run my simulation, and now I get very different results. So the interest rate is the blue line, and notice the interest rate's jumping all around. So not surprisingly, the interest, which is, the interest rate is green, which is jumping all around. So not surprisingly, the interest, which is blue, is kind of following it. So it's jumping around as well. And so the savings account is growing, but you can see it's growing at different rates. And so it grows kind of quickly here. It sort of slows down a little bit. It speeds up. It really slows down here. Notice it's got a kind of a corner, and then it starts picking back up again. So we can get more complex, rates of change here. So any questions about this output? Does this make sense what we did here? We just coupled time to the interest rate. Okay. All right, so how do we do that then in Insight Maker? So this is the old interface, but basically the controls are in the same place in the new interface. So it's easy to find them. They're just, all the names are the same and they're roughly the same positions. You go up to add primitive and you go down to add converter. Remember, converter is their name for lookup table in Insight Maker. It creates this differently shaped box here. And on the right-hand side, when you click on it, then it's got all of the information about the lookup table. In the new version of Insight Maker, it actually puts the lookup table right here on the right-hand side. In the old version, you had to click on a little equal sign and then it would blow that up to edit it. But you can actually edit right on the right-hand side here. So, but it's got a couple of settings that I want to focus on here. So one of the things here is under input source. There are shadow variables in Insight Maker. They're called ghost primitives, but time isn't one of them. The only ghost primitives in Insight Maker are just to make copies of everything else that you've drawn. It's not to get access to these hidden ones. Time is the big hidden one, and it knows that you'll frequently want to build lookup tables that use time as an input. So when you pull in a lookup table or a converter, right here on the right under input source, if you've connected things to it, this will be a drop-down box, and you can either select time as the input or one of the things you've drugged and connected to it. So that's all it is there. So we can default to time for this problem. And then notice it had this weird thing called interpolation. It defaults to linear. And so when we edit the lookup table, so these points will show up on the right-hand side when you're doing that. They're really easy to get to in the new version so before you had to click on this little equal sign and then it would pop up, but now they just put it right on that right-hand side. And you've got all your points here. And what this linear does is it kind of connects the points like Moorcroft does and like Vensim does. It creates them with straight lines. If I set this linear to none, then it puts them in steps. And so this way, I don't have to kind of create these false corners. This none makes it so that it holds this value until the next value. So I can very quickly go from linear to none, and it automatically adds these steps for me without me having to add in all these extra kind of false corners. Does that distinction make sense, linear to none? I mean, clearly the graphs look very different, is that, you know, all of the nones will always have these horizontal steps, whereas in the linears, it connects them with these kind of diagonal connections instead. But the lookup tables work the same. All right, so with that, I can build the same model that I did in Vensim, and I get the same output. So I've got my variable interest rate is the blue line. It changes over time, just like it did in Vensim. I've got my savings account balance. And so you can see it grows fast. It grows a little bit slower, fast again, slower, fast. So this looks different than Vensim because I think I used a different lookup table when I drew this, but the same idea here. If I use the same lookup table, I would have gotten the same out. So any questions on this? Lookup tables in time in Insight Maker. Okay. All right, now you can also do, as I said before, lookup tables based on inputs. So if you were to, if I instead was to link savings account balance into the interest rate, under input source, I could select savings account balance instead of time. And then I could create a lookup table that was based on the current savings account balance. So this would be like a bank where they're saying, under, you know, so like initially we'll give you a 10% interest rate, but if you give us more than $100, we'll raise that to 20. And that will keep going up so that when you're like $200, it'll max out at a 50% interest rate. No bank would do that, but you kind of see where I'm going with this. But if you end up getting more than $500 in your account, we'll bring it back down to less than 10%. So this is a thing where now we're making the interest rate depend on the savings account balance, not on the time. So that's another thing we can do with this lookup table. And by doing that, we can simulate and we get, like, here's the interest rate. You can see it as the savings account crosses those critical thresholds here, you see the interest rate jump up and down in these steps. But in this relationship here, you get this smooth growth, but you get like a rapid exponential growth and then a slow exponential growth and then kind of intermediate exponential growth here. So then this is your savings account balance, and that's the interest rate. Does that make sense? Any questions about that? Okay, questions online? With regard to which one's nicer, lookup tables in Insight Maker or Vensim, I kind of like the linear the interpolation linear versus none option. I kind of like that you don't have to dig for time in sort of in a shadow variable, but otherwise I think it's pretty much a tie. Which one's better? So, all right. So those are the three big things that I wanted to show you. Not a whole lot here. I think I gave myself a little bit more time because I wanted to make sure I could demo them. So before I do any of this sort of summary stuff, does anybody need to see any demos of those in Vensim or Insight Maker? Because I had the time. So I got here a little late. I was afraid I was running low on time, but looks like I had plenty. Anybody online, any other questions or need me to see something demoed? I do, maybe I actually do want to bring up, let me at least show you briefly, because it is a different interface, this, the Insight Maker version of these things. So, I mean, under Insight Maker, like I said, if I go into like converter, if I bring a converter in, then on the right-hand side here, you can see that it actually puts the lookup table immediately graphically displayed, and you can edit the points right down here, and you can edit the time source here. And if I scroll down, then it's got the interpolation option there, and I can choose my units as before. So, so this converter does have all the same options, but they're just in a very different format. So that's one of the big differences there. Otherwise, I think most of the other things that I demonstrated, I already had changed the units. I showed you how to do units already. The unit conversions I showed you. I forget what we did in between. But yeah, so the converter was sort of the biggest thing then that was different than the units. So yeah, so any like I said, is anybody need to see, oh, the sliders, that was the other thing. So if I bring in a variable inside here, I can go and edit its values down this side. And if I say enable value slider, I can put the slider here, and I can even specify things like what step do I want the slider? So do I want this as like 0.1 steps? So when I click on the, if I go back to new variable, enable slider, got my steps. Then down here, I can slide that around, and you can see it slides in these 0.1 steps. So that's something that, and I guess I'll save insight. So then now if it's saved, it gets rid of that box, and then now you can see when I click away, then it's got this slider here, and as I drag it, as I move it left and right, again, it moves in these 0.1 steps because I set that as a step size. And if I went and simulate, nothing's going to happen here because I don't have any stocks and flows. But if I went and simulated it, it would generate one plot. And then if I hit adjusted the variable and hit simulate it again, it would generate another plot, and I can put them next to each other to compare. So it's not quite as nice as Vensim, but it's not bad. It's still a lot faster than editing these things manually. So, all right, so those are the kind of the biggest differences between the old Insight Maker and the new Insight Maker. So you feel good about that? All right, so only other announcements here. So this is lecture E1. So we'll do E2 on Tuesday, E3 on Thursday. So E4 will be a week from Tuesday. So that's the first chapter we have to worry about, chapter 6 of Moorcroft. We're skipping chapters 4 and 5, although these are not bad chapters to skim through. When we start talking about delays next time, it does relate to some content in chapter 4, but I just didn't want you guys to take the time to read through it. Otherwise, there's a muddiest point on Canvas. Not a lot to talk about this week, just the stuff from today. Reading exercise E4, again, that's, you pretty much got a week and a half to worry about that. The biggest thing is this final project names of team members. I already mentioned this. It's due Sunday night. It's an individual assignment. Every team member has to submit it. That way I can make sure everybody agrees on who's in their team. Once you do that, I'll create groups on Canvas. And then every other deliverable after that will be a group assignment. So about, I don't know, a week or so after that, you'll have to submit a very short, 1.5, 2 pages max, a proposal where you're basically, and you can look online in the project proposal module for information about, or the final project module for information on the proposal. But basically, you say, this is the system I want to model. Give me a paragraph. Why is this a good system? These are the variables that I think there might be more, but these are the ones I definitely think are involved. It would be great. I think I actually might require it you'd have a basic causal loop diagram to say, not only these are the variables that are involved, but in my conceptual model, this variable has an impact on this variable has an impact on this. And so those are the things that I'm going to have to model. So that goes into your project proposal for me to review that, see if it's overly ambitious or too simple and so on, and give you some advice on that. And then after that, I pretty much leave you alone. But we do have a couple of times where we'll use time in class that you can use to work with your group. And then we also have a check-in assignment where you'll show me a basic simplified working version of your model, but that's not for quite a while. And then otherwise, assignment E2 is available. You can do question 1 purely based on what you've talked about today. Question 2 will require what I'm still talking about on Tuesday. So any questions about process going forward? Questions online? If not, then I skipped a couple of these because again, I thought I was going to be running way behind. But let's do the attendance exercise then. So I'm just putting it in the chat. And the question for today is, what does Insight Maker call its lookup tables? So if you want to add a lookup table in Insight Maker and you go to that add primitive, what is the thing down the add primitive menu that Insight Maker uses as its name for lookup tables? It's a name that we use more generically in the Moorcroft text, but they use specifically to talk about lookup tables. So if you don't remember, that's totally fine. Just put something that's coherent, graded for kind of coherence and completion, not correctness. And that's all I've got for you. So I hope you have a good weekend. If you have any questions about the midterm results, let me know. Any remaining questions online? If not, I will go ahead and end the room and rush back to my lab to try to fix an incubator. Have a good weekend.